Hi there, welcome to edupediaworld.com. You're watching the videos on lucid geometry. Now, in this video, we'll discuss lucid's definitions, axioms, and postulates. What are the various postulates of lucids? And as we has discussed in the previous videos, the lucid used to organize this definition and postulates in a book of elements. So we'll discuss the various postulates and axioms which are very commonly used in geometry, and we'll also discuss how the concept of point, surface, and or we can say line segment all came about, or how it can be used further to extend the concepts of geometry. And we'll discuss some very interesting concept why the mathematicians left some of the definitions of points or definitions of geometry undefined. So we'll discuss each and everything in this video only. So again, it's a theoretical video, theoretical concept and theoretical chapter, so you have to focus on this video very carefully. So let's get started with the first topic, which is introduction to Lucid's definitions, axioms, and postulates. Now, the Greek mathematician, as we have discussed, Thales of Lucid's time thought of geometry an abstract model of the world in which they lived. They thought that everything in this world can be formulated into geometrical concepts, or can be described into a model using mathematical geometry. So Greek mathematician Thales thought of defining each and every concept as an abstract model of the world. Now, the notion of point means the definition of point, line, surface, plane, and so on were derived from the what we have seen around them. Means if we see a building like this, square building or rectangular building, we can define this as a rectangle. So, and if we see a road like this, we can define it as a two parallel lines. So actually, Thales was trying to say that we can describe or we can define geometry concepts from the real world problems or real world situations. Now, suppose and from the studies of the space and solids in the space around them, like solids we see rocks or any buildings we see, these are all solids, and have an abstract model which we'll describe in this chapter only. Now, let me now clear how we can define the things. Let me clarify now. Consider three steps from solids to points. Suppose we have a solid like this. We have solid like this. You can say like this. Now this solid has three dimensions. Means it has breadth, length, and height. Now these type of shapes are generally known as solids. Now if we lose one extension means if we remove one dimension, it will convert to surface or planes or areas. Like this, if we convert this 3D figure into 2D figure, it can be like this, which is rectangle or square, anything it can be. Now if we further remove one extension, or if we remove one dimension, it can be converted into line. So then if we further remove the line, it can be converted to point. So this was actually the concept of lucids, that everything is related from point to 3D figures we see around the world. So if we start to lose one extension or we start to remove one dimension, we can get from solids to point or points to solid. So this was actual concept of lucids. So let's discuss the further concepts. Lucid's book of elements means we'll discuss some of the points of book 1 of the elements. A few of them are: a point is that which has no part. Means if this is a point, it has no part, it has no dimensions. But if actually you see the point like this can be a point, or this can be a point, or this can be a point. According to Lucid, a point is that which has no part, means it has no dimensions. But if you look at three different points, this point and this point, it has different dimensions. So this Lucid try to assume these type of postulates. It's an assumption, or we can say it's a again a universal truth. Now a line is breadthless line, means if we draw a line, it has no breadth. But if we actually see, if this is a line, let me draw it again. If this is a line, this can also be a line. So if these two lines have a different breadth, so again it is a assumption. Again this is a assumption or a universal truth. The ends of a lines are a points. Now if suppose this is a line, he was trying to say is that if this is the end and this is the end, these are the points. Now if we have a line but we have not defined the length of a line, then we cannot have an end of that line. So again this is a assumption that end of a lines are points. Why? Because if we define a length, it will continue to extend indefinitely, so it will have no end. So how we can define the points? So again these are the assumptions. Now a straight line is a line which lies evenly with the points on itself, means if we try to combine different points like this, it makes a line, or the points lie evenly on a line, means the point actually if we divide a line into into indefinitely equal parts, each will be a point. So that's again an assumption, because how much division we can do, we cannot have an definite end to that. Now again it's an assumption. Now a surface is that which has length and breadth only, means if this is a surface, it has only length and breadth. Again it is assumption, like which part we should take as a length and which part should we take as length. This can also become a length and this can also become a breadth. So again it's a assumption, or we can say it's a undefined term in the mathematics. Now the edges of a surface are lines. If this is a surface, now this can be also a surface and this can be also a surface. So edges of the surface are lines. So what he was trying to do is that every surface of the edges, like edges of any surface you consider in this world, should be a lines. But if we consider this figure only, these are lines, but for this surface there are no lines. For this surface again there are no lines. So again this is an assumption. A plane surface is a surface which lies evenly with the surface lines on itself, means plane surface is like this, which lies evenly with the surface lines on it, means again these are, if we consider the inner points, these are again the lines. So again it's an assumption. Now so let's discuss further concepts of lucid geometry, some of the postulates which we are going to use in this chapter. So starting with his definitions, Lucid assumes certain properties which were not to be proved, means there were certain properties of geometry which are assumed to be again universal truth, which are not to be proved, means you cannot prove them because it's naturally existing, or it's a fact of a universe. So you cannot prove them as a using a mathematical model. Now these assumptions are actually obvious universal truth. He divided them into two types, axioms and postulates. Now from here we'll discuss what are axioms and what are postulates. He used the term postulates for assumption that was specific to geometry. Like in the previous slide we were discussing all the postulates of a lucid geometry, means which are assumed to be true or they are universal facts. Common notation often called axiom. Axioms are actually, if postulates, if we have a postulate, we can say axioms are actually extension of postulates. So they are derived from postulate. So which are the common notations, or we can say common terms for the axioms are the common terms for the postulates. So Lucid's axioms not in his order are given below, means these are some of the 7 Lucid's axioms which we will discuss further in the topics. Now things which are equal to one thing are equal to another thing, means like suppose, let me repeat it. Now things which are equal to the same thing are equal to one another. Suppose we have two lines like this. If they are, if this line, if the line number 1 and this is line number 2, if line number 1 is equals to line number 2, then this means that line 2 is also equals to line 1. Means if one line is equal to another line, or one thing is equal to the same thing, it should be line only. Doesn't mean that line, you are comparing line with a box. You have to compare line with a line only, and if they are equal, then they are equal, vice versa. Now if equals are added to the equals, the wholes are equals, means if we add area to area, we'll get area. Means we have to add equal things of same we can same category, or we can say we have to add the same things only. If equals are subtracted from equals, remainders are equal, means if we subtract area from area, we'll get remainder as area. Now things which coincide with one another are equal to one another, means if this is a line AB, and from here we draw another line to C, BC. Now these two lines are of equal distance. This means AC is equals to AB plus BC, means these lines coincide. So this is meaning of coincide, that things which coincide with one another are equal to one another. The whole is greater than a part, means suppose we have we can say this square as B, and we get another square from B which is a small square, this part of this square as A. This means A is a part of B. This means B is greater than A. So the whole is greater than a part, means the whole B is greater than a part A. Things which are double of same things are equal to one another, means suppose we can say if this is a line of 6 centimeter and this is a line of 3 centimeter. Now these two are lines, so they are same things. Now this line is double than this, so this means if we divide this line to 2 equal half, then these part will be equal to each other and also equal to the this line. Now things which are halves of same things are equal to one another, means suppose we have line again as 6 centimeter. If we divide it into 2 equal part like 3 centimeter or 3 centimeter, if we divide into 2 equal half, this means these two lines are equal. So these are the some of the axioms of the Lucids, so which we will discuss through the questions. Now let us discuss the 5 postulates of Lucids, which are very important. And but the first 4 postulates, like 1 to 4 postulates, are very simple and they not need to be proved. They are actually universal fact. But fifth postulate, which we will discuss in greater detail, is little bit complex and which needs again further extension, how we can simplify that postulates. So you have to watch the videos carefully. Now the postulate 1 says a straight line may be drawn from one point to any other point. Means if we have 2 points like P and Q as in the figure above, we can draw a line from this point to this point. Now note that this postulate tells us that at least one straight line passes through 2 distinct points. Means there has to be one at least line that passes through 2 distinct points. 2 distinct points means 2 different points. But it does not say that there cannot be more than one such line. Means what it's trying to say is that suppose we have 2 distinct points like P and Q, then only you can say only one line can pass through these 2 points. Means we cannot have another different line. If we draw a different line like this, suppose if we try to draw a line like this, suppose it's of different color, so that line will be actually the same line. So we cannot have two different line passing through two different distinct points. What he's trying to say is that we can have only one line that passes through two distinct points. Now, however, in his work, Lucid has frequently assumed, without mentioning, that there is a unique line joining two distinct points. That is, there is only a unique line that joins the two distinct points. So this is the first postulate of a Lucid. Now, its axiom is that given two distinct points, there is a unique line that passes through them. Means, suppose this is a point P, this is a point Q. Means we can have only one distinct line that passes through P and Q, but we can draw unlimited line passing through a point like this, like this. We can draw any number of lines like this. If we have line like this, we can draw any number of line passing through point, but if we have 2 points, there is only one line that joins the 2 points. So this is the first postulate of a useless. Now the second postulate, let's discuss the second postulate. The second postulate says that a terminated line can be produced indefinitely. Now let me define what is a terminated line. Suppose when we draw a line of 6 centimeter, it is actually a terminated line because it has a fixed line like PQ 6 centimeter. Now if anybody says you draw a line, so how much length? There is no end, so you can draw like continuously, but there is no end. But if anybody says you draw a line segment of 7 centimeter, then you can have an end to a line. So that is actually a postulate too. And note that we can call a line segment nowadays what Lucid called a terminated line. So for terminated line, they use in ancient times, they used to define a line segment nowadays we call as a terminated line. So according to the present day terms, the second postulate says that a line segment can be extended on either side to form a line. Means, suppose we have a line segment of 6 centimeter. Then if we want to extend this line, we can extend this line to unlimited side on either side to form a line. Means we can convert a terminated or we can say line segment to a line. So that is actually a postulate 2. Let's discuss the postulate 3. The postulate 3 says that a circle can be drawn with any center and any radius. Means if we have a line like this, if we take a this as center, we can draw a circle. Means we can draw any circle with center or any radius. We can take any radius. So that is actually a postulate 3. Now, let's discuss the postulate 4. All right angles are equal to one another. Means if we draw a right angle like this, suppose this is a right angle, or we draw a right angle like this, or we draw a right angle like this, these all right angles are equal to each other. So this is a fourth postulate. Now let's discuss the fifth postulate, which is very interesting postulate. The fifth postulate says that if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles. Now what is trying to say that suppose we have two lines like this, and if we fall a straight line on two lines like this, then the angles, the interior angles are like this one and this one, or we can say angle 1 and angle 2 on the same side, or either it can be left or right. If the sum of the angle 1 plus angle 2 is less than two right angles means 180, then let me select this, is sum of the angles angle 1 plus angle 2 is less than 2 times right angle, or we can say angle 1 plus angle 2 is less than 180, then this means the lines, this line, a line we can say L and M, will will intersect at a point. What he's trying to say, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. Means if the interior angles, angle 1 plus angle 2, is less than 180, then ultimately the line P and Q, they will, if we extend them, they will meet at a common point. So that is actually a postulate. Let me try to explain through example. Suppose we have a figure like this. For example, the line PQ falls in the figure on lines AB and CD such that the sum of interior angles, angle 1 and angle 2, is less than 180 on the left side of PQ. They are on the left side of PQ and they are interior, and they are less than 180. Therefore the lines AB and CD, means this line and this line, will eventually intersect on the left side of the PQ. Means they will intersect on the left side of the PQ. Means now this further extends to a concept of lines and angles, which we have studied in 8th standard also, that if we have a two parallel lines and we draw a transversal, then the sum of interior angles like angle 1 plus angle 2 form a angle 1 plus angle 2 form a pair of co-interior angles. Co-interior angles, and angle 1 plus angle 2 is 180. Means if angle 1 plus angle 2 is exactly equals to 180, then the lines, this line P and Q, are parallel and they will never meet. They will never meet. This actually postulates is trying to explain that if angle 1 plus angle 2 is less than 180, the lines will eventually meet. But if the line angle 1 plus angle 2 is exactly equals to 180, then the lines are parallel and they will never meet to each other at any point in the future, or any point until and unless we are trying to extend it. Now this is actually a postulate 5th. Now we'll try to explain each and every thing through the examples, and these type of questions are generally seen in examination, so watch the question carefully. If A, B and C are the 3 points, these are the 3 points on, and B lies on AC, then we have to prove that AB plus BC equals to AC. Means if these are the 3 points A, B and C and they lie on a line, then we have to prove that AB plus BC equals to AC. Now how we can prove that? Now in the previous slides we have discussed an axiom that things we can say like things which coincide with one another are equal to one another. Means we have discussed in the previous slides also that things which coincide with one another are equal to one another. Means these 3 points are coinciding. Means if AB, line AB is coinciding with line BC, then we can say that AB plus BC equals to AC according to the axiom number 4, or we can say axiom we have discussed in the previous video. So this is how we can solve the example through using the axiom. Now let's discuss a second example. We have to prove that equilateral triangle can be constructed on any given line segment. Now this is a very interesting question, so watch the question very carefully. Suppose we have a line segment as given in AB, and we want to draw a equilateral triangle on this line segment or terminated line. So what we'll do is we'll take A and B, we'll take A as center and we'll draw a circle and then we'll take B as center, and then again we draw a circle. Let me repeat again. We take A as center and we draw a circle, taking A as center. Then again we take B as center and we draw a circle, taking B as center, like this in the figure above, like this curve and like this curve. Now the point where they meet, like this point, point C, at this point we can join AC and CB. So all the three lengths will be equal. So this is how we can construct a equilateral triangle through a line, or we can say a line segment. Now this actually, this example actually leads to another theorem which are generally used in questions, that two distinct lines cannot have more than one point in common. Means, suppose, let me explain you now. Suppose we used A as center to draw a circle, and we used B as center to draw a circle. We used two distinct points to draw a circle, and they meet at a point another at C. So we have three distinct points to join two lines. Means we can join this line to this line, but we cannot join this line again with this line. So this actually leads to postulate that two distinct lines cannot have more than one point in common. So let's discuss that theorem. The theorem is two distinct lines cannot have more than one point in common. Now we need to prove this theorem. So let us suppose, no, let us suppose how we can prove this theorem. Let us suppose we have two intersecting lines, like we can say two intersecting line in two distinct points, say P and Q. Means we have two intersecting line like this, P and Q, at two distinct points. These are the two distinct points, and so you have two lines passing through two distinct points. Now you have two distinct lines, like you have two different line, like P and Q. They are passing through two distinct points. No, two distinct points, but this assumption, this assumption actually clashes with axiom that only one line can pass through two distinct points. So so the assumption we started, that the two lines P and Q passes through two distinct points, is actually proved to be wrong. So we can say that we need two distinct line cannot have more than one point in common. So this is actually the postulate that proves the postulate that there is only one line that can be passed through only one point. So means there is only one point common in one line only. So this is the theorem. Now thank you once again for watching this video on edupediaworld.com. Keep watching further videos. So in the next video we'll discuss the extension of fifth postulate of Euclid, so which is very important from the exam point of view. So thank you once again. Have a nice day.